Hello, I'm Sina Moallemi and I'm the product manager for RS3. In this video, I want to introduce to you Discrete Fracture Network, one of the most innovative features that we have in RS3. Jointed rock masses are very common in many engineering applications. Modeling their behavior correctly is important to keep structures like tunnels, foundations, and a slope safe. In RS3, you can model jointed rock mass with three different approaches. The first approach utilizes the Hooke-Brown failure criteria, ideal for capturing the nonlinear strength characteristic of rock masses. Both Hooke-Brown and generalized Hooke-Brown models are available in RS2 and RS3 material library. The second approach employs an anisotropic constitutive model, where the mechanical behavior of both intact rock and joint sets are defined. In this approach, joints are modeled implicitly to reflect the anisotropic behavior in the model. Lastly, using DFN tool, you can define discrete fracture network explicitly by entering few stochastic parameters to define the orientation of the joint and the spacing between them. So now let's go to RS3 and see how we can assign DFN to our model. So I already opened the model. Here you can see the geometry of the slope. I have already assigned material property to different volumes. Now let's define DFN and then assign it to the model. So I go to Material, DFN, define DFN. In the tool, you can define both parallel joints and cross joint, or any combination of them. Let's define a set of parallel joints for this example. In the property section, you can define or edit the property that you want to assign to the joints. The joints can be either infinite, or you can define different shapes for the joints, or you can define the dimension, the size, and the persistence of the joints. For this example, I'm going to go with infinite joints. For spacing, you can use either uniform spacing between the joints or different stochastic distribution for spacing are available. So here you can see we have normal distribution, exponential, or log normal. I pick normal distribution and enter mean, standard deviation, relative mean, and relative max. If you click preview, we can see the distribution of joints. We can also change the orientation of the joint. So I'm going to change the dip and diff direction. And click preview. Here you go. With only few parameters, the DFN is created. So I click OK. And now let's see how we can assign it to the volume. I change the selection mode to entity selection. I pick the entity that I would like to assign the DFN to. Then I go to Material, Discrete Fracture Network, add DFN. Since we only had one DFN, there is only one option here. And I click OK. And now you can see the joints is applied to that volume. In order to see the effect of the joints, I have run the SSR analysis for this model. So let's go and open the model and see the results. By default, you can see the sigma 1 distribution, but let me show you the displacement and display the results at the critical SRF equal to 2. To see the effect of joints, let me define a cutting plane and place it at the location where we have the maximum displacement. Click Add. Now I'm going to hide everything and keep the cutting plane. As you can see, the discontinuity in the results is so clear, showing the sliding of the slope over these weak plates. In this video, we learned how easily we can create and apply DFN to RS3 model. Thanks for watching. If you have any questions, please leave in the comment section below.